Hello friends and welcome to this video. We are going to discuss the fourth topic from this chapter number 6 titled as adaptive filters, and the topic here it is the LMS algorithm. Already we are covered with the three topics. Those were the adaptive filtering system identification, introduction to the term adaptive, and the filtering aspects we have discussed thereupon. Then we started to have design of the FIR adaptive filters, and in this regard thereupon in the previous video, the third topic, we have learned the steepest descent algorithm here. Now a discussion is to be continued here, and the LMS algorithm is having the advantages over the previous, the steepest descent adaptive filter. So in the previous video, the development of the steepest descent adaptive filter we have seen. So it is having a weight vector update equation that can be denoted as W suffix n plus 1 equal to W suffix n added by mu times the expected value of the multiplication of small e of n with the complex conjugate of x of n here. So to recall back the block schematic that we have seen in the first video titled as adaptive filtering system identification, I hope you remember the two signals x of n, the input discrete time random process, and the desired signal d of n. The difference of the two in that block schematic that we have represented as small e of n here. So now as we see the second term of the RHS here, so it is mu multiplied by, mu is the step size that we have discussed in the previous video. So this step size is in multiplication to the expected value of the product of the error signal e of n with the complex conjugate of x of n here. So there it is one practical limitation with the use of steepest descent algorithm having such a mathematical representation in this particular equation, that the second term that involves the expectation capital E of the product e of n with the complex conjugate of x of n is mostly unknown here. So therefore this particular term should be replaced with an estimate such as the sample mean. So this can be denoted as capital E cap of the multiplication e of n with the complex conjugate of x of n here. It will be given by 1 upon capital L in multiplication to the summation operation for the index variable L is equal to 0 to capital L minus 1 for the product of e of n minus L to the complex conjugate of x of n minus L here. Now here when we incorporate this particular estimate and make changes to the mathematical representation that we have seen for the steepest descent algorithm in the previous video, the update equation for the weight vector denoted by W suffix n will become W suffix n plus 1 is equal to W suffix n added by mu divided by capital L multiplied to the summation as it is L is equal to 0 to capital L minus 1 for the multiplication of e of n minus L to the complex conjugate of x of n minus L here. So if we see a special case to this particular equation, so the use of 1 point sample mean will be obtained when we have capital L is equal to 1 here. So there we can represent capital E cap of e of n into the complex conjugate of x of n. So this is equal to e of n into the complex conjugate of x of n simply here. So in this case the weight vector update equation will assume a particular simple form given by the mathematical representation W suffix n plus 1 equal to W suffix n added by mu multiplied to small e of n with the complex conjugate of x of n here, and this particular simple form of the update equation is known as the LMS algorithm here. The simplicity of the algorithm is coming from the fact that the update for the kth coefficient as represented here W suffix n plus 1 of k, it should be on the left hand side, given by the w suffix n of k added to mu multiplied by e of n into the complex conjugate of x of n minus k will require only one multiplication and only one addition here. So the value of mu to that of e of n need only be computed once, and it may be used for all the coefficients here. So therefore the LMS adaptive type of the filter, LMS standing for the least mean square, so least mean square adaptive filter having the p plus 1 coefficients require p plus 1 in general multiplications and p plus 1 additions to update the filter coefficients here. So this was the required information with respect to the most popular but the simplest topic of the adaptive filters called as the LMS algorithm here. Possibly in the next video we shall see a practical demonstration of the same, and will continue into the same chapter to address the convergence of the LMS algorithm as the next topic. Thank you.